Right, in this video we're going to be taking a look at a circuit which is a series circuit, and it's got a parallel circuit built inside it. How do I know it's parallel? Because at this point over here the current actually splits off into two different parts and it rejoins over here. So we know the current through this and the current through that will be exactly the same. And then what I'm going to do is I'm going to work out the voltage, current and the resistance for each one of those resistors over there. So the first thing we're going to do is we're going to calculate the total current in this circuit. So before we do anything, we know the total voltage is 6 volts. The total resistance in this case, we've got a parallel circuit there plus a series, so we're going to treat that as one system and we're going to add it onto that. So we're going to say 1 over 14 ohms plus 1 over 20 ohms plus 4 ohms. So that's the parallel bit over there, and I'm going to treat that as one resistor, and I'm going to add it onto that 4 ohm resistor over there. So we're going to do that and see what we get as the total resistance for this circuit. So we've got 8.23 over there plus 4. So we get 12.24 ohms for that one. To work out the total current in the circuit, I'm just going to do VT all over RT, and we get an answer of 6 divided by 12.24. So 6 divided by my answer there. And we get 0.49 amps. So that's the total current running through that circuit right now. So what we're going to do now is we're going to work out the current, voltage and resistance for each one of those different resistors out there. So the first thing we're going to do is we're going to look at R1 and then R2 and then also R3. So the easiest one to do, actually, you can start with any one of these, to be honest with you. So what we're going to do is we're going to start off with this R3 over here, because we know the current through it. The current will come here, it will split off, and then it will rejoin over here. So the current is the total current. So the current for this one, I, is 0.49 amps. The resistance for this one is 4 ohms. So V is going to be, V is equal to IR, so 4 times by 0.49. And we get an answer of 1.96 volts. So that's my total voltage on that one. Over here for R1, I'm going to say that the current comes down. Each one of those electrons comes, it splits off. Each one of those electrons is carrying 6 volts. So the voltage for R1 is actually 6 volts, and the voltage for R2 is 6 volts as well. We know that R1 is going to be, the resistance is going to be 14 ohms, and the resistance for this over here is going to be 20 ohms. So now we can actually calculate the current quite easily running through each one, because all we do is we do V6 divided by 20 for R2, which is 0.3 amps, and for this one it's 6 divided by 14, which is 0.43 amps. So has this worked? 0.43 plus 0.3, 0.73. I'm pushing out too much current in this one. So I realized I was pushing out too much current. I was pushing out 0.73 amps, and the total current was only 0.49 amps. So I'd made a mistake somewhere. So the mistake in this one is actually over here. The mistake comes because R3 is perfect. R3, the voltage on it is 1.96 volts. So that means the total voltage of these two, the total voltage of this system over here plus the voltage over there must add up to 6. So therefore 6 minus 1.96 gives me 4.04 volts. So this here must be 4.04 volts, and this over here must be 4.04 volts. So I've taken the 6 out and I've put 4.04 volts for that one, 4.04 volts for that one. The resistances haven't changed, and then I can work out my total current for this one is the total current running through R1 is 0.29 amps, and the total current running through R2 is 0.2 amps. And the way you do that is you just divide V divided with R. So you get that forgot the units there. Does this add up to 0.49 amps? Yes, it does. 0.2 plus 0.29 is equal to 0.49 amps. So it does add up. So the total current is right. Everything is right for R1, R2, and also R3. Thank you.